Hello, seniors. This lesson is about horizontal and vertical asymptotes. The definitions are based on the limits. Function f of x will have vertical asymptote at x equals a if at least one of the following is satisfied. So basically, this just simply means if you evaluate the left hand and the right hand limits of a value of x as x approaches a value, and you have infinity as your answer, it's a vertical asymptote at that value x equals a. And for horizontal asymptote, if you evaluate limits at infinity, at negative infinity, and at positive infinity, if the function approaches a value a, then it's a horizontal asymptote at y equals a. Okay, so we will use these definitions of the asymptotes to graph in particular rational functions. So here are basic steps. First, determine the domain of the function. We will base our left hand and right hand limits of values approaches the restrictions of the domain. That's step 2. Now, evaluate limits at positive and negative infinity to test for horizontal asymptotes. And number 4, of course, we need some points to graph our function. So just get some points and connect those points, observing correct behavior as suggested by the limits. Let's have this example. F of x equals x squared plus 1 over x squared minus x minus 2, a rational function. Before we get the domain, that's step 1. Of course, we need to factor this, and it's x minus 2 times x plus 1. The numerator is x squared plus 1. Okay, the domain, that's the first step. Get the domain. The domain, x cannot be 1, no, negative 1, and 2. So we'll make values, so we'll make this 0. So we have 2 restrictions to the domain. We'll test those values for vertical asymptote. Simply get the left hand and the right hand limits. So limit x approaches negative 1 from the left and negative 1 from the right. Now negative 1 from the left will make this a negative infinitesimal. This is a negative, so positive infinitesimal. The numerator will always be positive because when you square that, it becomes 1 plus 1, 2. So we'll get here negative infinity. So negative 1 from the right will make this infinitesimal positive, but this will become negative. That's positive over negative. Positive over negative will be negative infinity also. Now, let's check again. Negative 1 from the left. Negative 1 from the left will make this negative, negative, positive. So this should be positive infinity. So there. Okay, so we evaluated left hand and right hand limits of our x as x approaches negative 1, and we get infinities. Therefore, we have a vertical asymptote at x equals negative 1. Okay, now let's have the left hand and the right hand limit as we approach the other restriction to the domain, 2. So 2 from the left, and x approaches 2 from the right. Now 2 from the left will make this a negative infinitesimal. This is positive. The numerator is 2 squared plus 1, 5. That's a positive. Therefore, this is a negative infinity. 2 from the right will obviously make this a positive infinitesimal. Then positive, positive. The numerator is also 5, positive. So positive over positive is positive infinity. Again, we have infinities as our limits. Therefore, we have another vertical asymptote at the x is equal to 2. So we have 2 vertical asymptotes. Now to test for horizontal asymptotes, we simply evaluate our function as x approaches infinity. So limit x approaches negative infinity, and the limit as x approaches positive infinity. In this case, we have a rational function of the same degree. The numerator and the denominator have the same degree, and the limit at infinity is both equal to 1. And again, according to the definition, if you have a value, that's a, that's a value, that's a horizontal asymptote. So therefore, you have a horizontal asymptote at that value that at infinity, y equals 1. Okay, so in graphing this, let's graph our asymptotes first and get some points left and right of the vertical asymptote, and connecting the points following the behavior suggested by the limits, that this behavior. Okay, let's use this graph. So let's graph our asymptotes using what? A red line. So no, let's make it green. No, I want it red. Yeah. So we have a vertical asymptote at x equals -1 and x equals 2. So we have two vertical asymptotes. This red line, remember, is an asymptote here. And we have a horizontal asymptote at y equals 1. So there, this. Okay, now let's get some points left and right of our asymptote. Remember, our asymptotes are this one. This is x is equal to -1. This line is x is equal to 2. So to get some points, simply get let's say -2. So if x is -2, what would be our y coordinate? So -2 squared, that's 4 plus 1, 5. -2 squared, 4 minus -2, that's 6 minus 2, 4. So we have 5 over 4. So we have here 5 over 4. Okay, so where's this point? Let's plot it later. So we can also use the point 0. And the y coordinate would be 0 squared plus 1, 0 minus 2. That would be 1 over -2, it's -1/2. So we have the point 0 and -1/2. Then we can use the point 3 to the right of the second asymptote, x equals 2. So if x equals 3, you have 3 squared 9 plus 1, that's 10. 3 squared 9 minus 3 is 6, minus 2 is 4. So you have 10 over 4, that is 5 halves. Then 3 5 halves. Okay, now let's plot the points. So plotting -2 and 5/4. -2 and 5/4 would be -2. 5/4 is 1 and 0.25, somewhere here. Okay, the point 0, -1/2 would be, of course, 0, and the -1/2 somewhere here. The point 3 5/2 is 1, 2, 3. 5/2 is 2.2.5, so it's here. Okay, now all we need to do is to observe the behavior as suggested by the limits. So let's start in this point. It says, as we approach the asymptote -1 coming from this point, so we are approaching the -1 from the left side. So -1 from the left side says positive infinity. Therefore, from this point approaching the asymptote, we should go up to positive infinity. Okay, and as we approach from this point, as we approach negative infinity towards the negative infinity, says in the limit, you'll approach 1, positive 1. Therefore, this would be a curve not touching the asymptote. Yeah. Now, let's have this point. This point will approach the asymptote 2 from its right side. Therefore, what's the limit as we approach 2 from the right side? It says here, positive infinity. So therefore, we go up. Approaching 2, we go up. Like that. And as we approach positive infinity, we will approach 1. So as x approaches positive infinity, this is up to 1 only. So there. So that's the graph. So the middle part. So we have a point here. And as we approach the asymptote -1 from the right side, -1 from the right side says negative infinity. Therefore, there is no way to go from this point approaching -1 but go down. And so you approach -1 from the other asymptote 2 from its left side says also negative infinity. So therefore, you go from that point going down. So that's the graph using limits. Now I want to show you the exact graph of the function using the Microsoft Mathematics add-in graphing tool so that you can check. Okay, so Let's exit this. So remember, our function is x squared plus 1 over x squared minus x minus 2. So we have the function x squared is at minus 1 over x squared minus x minus 2. I think it's plus 1, right? Yes, x squared plus 1 over x squared minus x minus 2. Okay, let's graph this. Please wait. And that's the graph. So you see, we have an asymptote at the line -1 and +2, and horizontal asymptote at 1. And this is our graph. This is the actual graph. So if you have any questions, again, you know where to find me. I'm at room 508, and if I'm not there, I'm exploring the 8th floor. Good day, seniors.